this one is oil. Here velocity is 0, and this is the linearizations of Newton's law of viscosity problem. This is the velocity distribution for linearizations of Newton's law of viscosity. This one is 1.5 meter per second, and height is 3 millimeter into, convert is the SI unit, meter, meter, and mu equal to mu of oil 0.2 Pascal per second. So this is the lower plate, this is the lower fixed plate. Lower fixed plate velocity is 0, so shear stress mu into V minus 0 by H. So mu value is 0.2, V is 1.5, H into H equal to 3.10 to the power minus 3, and the value of shear stress is 100 Newton per millimeter square. Suppose dy by dy in the fixed plate tau equal to mu into du by dy. In the fixed plate, in the fixed plate, in the fixed plate, du by dy not the function of y, so u equal to not a function of fy, and shear stress is a not function of fy, function y. Understand? Now another problem is a 90 Newton rectangular solid block. This is 90 Newton solid block, and the 30-degree inclined plane, and the plane is lubricated by 3 meter thick. This is the H, 3 millimeter, okay, 3 into 10 to the power minus 3 meter, and relative density of oil. The density of oil, relative density means gamma is specific gravity, 0. Specific gravity is 0.9. Sg of oil is 0.9 specific, and viscosity of oil, mu equal to oil is 8 poise equal to 0.8 Pascal per second. Contacting area, this area is 0.3 millimeter square. Terminal velocity means this terminal velocity calculates. First of all, this one, and this 30 degree, this weight is divided into two. One is, and how to measure this angle and this angle. You never seen, I think you never seen how to measure this angle. Suppose this is a 30 degree, and this one is, suppose this is theta. This inclined plane, the vertical is 90 degree minus theta. Understand? Now draw a perpendicular. Draw a perpendicular. This one is, and this the parallel of the this one. Understand? Incline parallel, incline perpendicular is angle is 90 degree minus theta. Suppose this is the P, this is 90 degree minus theta, this one obviously theta. You see, this is incline, this is vertical, the angle between them is 90 degree minus theta. So first we draw a perpendicular of the inclined plane and the parallel of the inclined plane, and divided them by P. This is another plane, and this vertical and inclined angle between this inclined and vertical plane, this vertical and this is in same 90 degree minus theta, and this is obviously theta, so this is a P cos theta, and this is the P cos. And when suppose this is the P, this is the P, and this is the theta, so P cos theta. Always you remember, theta angle makes which plane? This always must always the P cos theta, and another one is P sin theta. So this is the P cos theta, so this one is P sin theta, or you can say P cos 90 degree minus theta. 90 degree theta means P sin theta. Understand this logic? And this case, this is the parallel, this one is parallel, this one is parallel, and this is the, suppose 60 degree, this is the 60 degree, this is the 60 degree. So inclined and vertical is, inclined vertical is 60 degree, and this one is obviously 30 degree. So this is the 90 cos 30 degree, and this one always obviously 90 degrees sin 90 sin 30 degree. Understand? Now summation of the equilibrium condition is applied at this problem. This is the summation of f equal to 0 at this angle and this one is 90 degree uh, inclined by 90 sine 30 degree minus this is the, and this the 90 degree 90 sine theta acting downwards, and frictional resistance offered by the fluid is F, upward direction, incline upward direction. So this is the F equal to 0, and this is frictional force into shear stress into area, shear stress into area, and shear stress into area. Shear stress equal to, this is the linearizations of viscosity, linear Newton's law of viscosity. So mu into V into H, mu value is 0.8, and velocity is V, and height is 3 into 10 to the power minus 3. So this value is 26.67 V Newton per meter square, and put this value, this 90 sine 30 degree, sine 30 means half, F equal to F into area equal to 0. This is 45, and mu value is 26.667 into V into area is 0.3 equal to 0. So the terminal velocity of the block 0.5625 meter per second. Understand how? The next problem is the calculate capillarity effect in millimeter in glass tube of 4 millimeter, and when immersed in a water, and we capillarity, we know capillarity rise or depression H equal to 4 sigma cos theta rho GD. Understand? For water and glass interface, this is the capillarity rise. For capillarity, H equal to for capillarity rise, H equal to water value is surface tension of water 73575 into, this is, suppose this is pure water. For pure water, the contact angle of contact is 0 degree, and the density of water 0.998, and this is 9.81, and diameter of the glass tube 4 into 10 to the power minus 3. Oh, this one is sorry, this one is 998. So capillarity rise equal to, for water, is 7.51 into 10 to the power minus 3 meter, অর্থাৎ 7.51 millimeter. In same case, capillarity for mercury depression 4 into sigma Hg 0.51 into cos 130 degree for this is the density, and density of mercury we know 1300 into 9.81 into 4 into 10 to the power minus 3, and the value is minus 2.457 into 10 to the power minus 3 meter, অর্থাৎ 2.457 minus millimeter. This is the, from this minus sign indicate this is the depression. Capillarity indicate capillarity depression. Capillarity depression, this minus sign indicates. Next topic is compressibility. What is compressibility? It means ability to compress, ability to get compressed or compressibility is the another is volumetric strain per compressive stress. Compressive stress, and this compressive stress, pressure on the means pressure on the fluid, this is the liquids, and this is the compressive pressure. So the formula is denoted by beta. So beta equal to volumetric strain sigma v into dp, and here minus dv by dv, here dv equal to vf minus v, where vf less than v. This minus indicate compressive. Indicates compressive. Now mass equal to rho into volume into density. From the mass is constant, so constant from the law of conservation of mass, neither destroy nor created. So d rho into v plus d rho into dv equal to 0. So d rho into v equal to minus rho into dv. So d rho into rho minus dv by v. So the compressibility equal to this value is putting d rho into dp. This is the another equation. This is the another equation, and this beta is this beta is the function of rho, and one is rho is the function of p. So d rho by dp not equal to 0, and so beta equal to not equal to 0. This is compressive material. Compressive material bulk or fluid material or fluid. And another point is rho is not function of p, so d rho into dp equal to 0, so or beta equal to 0. This is the incompressible fluid or material. Understand the points. Next topic is bulk modulus. Next topic is bulk modulus is denoted by K. Author, the K equal to, it is the ratio of bulk stress or compressive stress divided by bulk strain or volumetric strain. অতএব B equal to 1 by compressibility.